Hello all. So in this video I am going to explain about rank of matrix for the matrices for which m is not equal to n. Previously I explained rank of matrix in the case of m is equal to n, that is order. Okay, that is a square matrix. So square matrix rank over. So next rectangular matrices. So here we have two types. For that, first m is less than 1 and next one is m is greater than 1. So rank of a for m is less than n, rank of a is less than or equal to m, which is smaller one. So here also in the case n is small, so rank of a is less than or equal to n. For example, here I took one example 1 2 3 2 3 4. So here m means number of rows are 2 and n is number of columns are 3. Okay, so for this, how to find out rank of a means we need to take one minor. So we can't find out det of this directly, because for det this m is equal to m and n should be same. So that I am taking one minor 1 2 3 4. So det of 1 2 3 4 is equal to how much? 1 into 4 4, 2 into 3 6. So answer is minus 2, which is not equal to 0. So that rank of a is equal to 2. That is order is 2 by 2. So rank of a is equal to directly 2. And for this, number of rows are 3 and number of columns are 2. So it is a 3 by 2 matrix. If we observe here, m value is same, that is equal to m. So less than or equal to m. And here also I am taking one minor 1 2 3 6. And the det is 1 into 6, 6 minus 2 into 3, 6. So that we got 0 here. So next minor 3 6 2 6. So 3 6 2 6. 18, 3 6 are 18 minus 6 2s are 12. So answer is 6. So which is not equal to 0. So that this order is 2 by 2. So that rank of a is equal to 2. If this also we got 0, we need to check for 1 2 2 6. That is minor 1 2 2 6. And for this, if also we got 0, then there is no possibility of minus 2 by 2. So directly 1, that is 1 by 1, that is 1 2. So det of 1 is 1 only. So that rank is 1. Okay, like that we need to find out rank of matrix for rectangular matrices. Next is very important, system of linear equations. So what are the solutions for this system of linear equations? So for example, here generally the equations are a11x, a12y. So like that he will give the problem. So how to find out the solutions for these equations and the nature of the solutions. So step 1, construct argument matrix A is to B. So what is A and what is B means, here the coefficients of x, y, z in the form of matrix gives A. That is A11, that is x quotients, y quotients, z quotient. First equation is A11, A12, A13. Second one is A21, A22, A23. Third one is what? A31, A32, A33. Okay, so this is the matrix of A. Then what is matrix of B? This is the constant values in this side. That is B1, B2, B3. Okay, so right. Now construct A is argument matrix A is to B. That is A11, A12, A13, A21, A22, A23, A31, A32, A33. Next B1, B2, B3, B1, B2, B3. This is the argument matrix for A and B. Okay. After that, convert A into upper triangular matrix. Upper triangle matrix means lower these three upper triangle matrix for A. So in the A matrix, these three we need to get zeros, so that this is converted into upper triangular matrix. That is A21, A31, A32. A21, A31, A32 should be 0. So that we'll get some form like this. A argument matrix is A11, A12, A13, Yeah, this will get zeros. We need to get 0. Next this one 0, 0, A33. And we don't know these value, we will get values or zeros also. If we get 0 here, what happened to rank of only A? That is the number of non-zero rows. So that already I told you. The rank of A is what? Number of non-zero rows. Rank of A is equal to number of non-zero rows in matrix A. And here rank of argument matrix, number of non-zero rows in AB matrix. If we will get 0 here, rank of A should be 2. And here if we get number and here 0, the matrix non-zero means here we got some number, right? So that number of non-zero rows are 3. So that here we will get 3 and here we will get 2. So the 2 is not equal to 3. So I will explain next step. Now depending on that, if rank of A is not equal to rank of argument matrix, then that equation have no solutions. Okay. Now next one is if rank of A is equal to rank of argument matrix. Okay, but if that is equal to order of matrix A, n. Okay, let the order will be n by n matrix. So if that rank we got should be n for both, then that solution is unique solution. So the equation have unique solution. And next, if rank of A is equal to rank of argument matrix, but it is not equal to order, then that equations have infinite solutions. So in our exams, the option should be the equation should have unique solutions, no solutions, infinite solutions, like that. For that purpose, this is the process. Okay, I'll explain this one. It's one example. So here 2x plus 6y is equal to minus 11, 6x plus 20y minus 6z equal to minus 3, 6y minus 18z, right, is equal to minus 1. So these are the three equations. Now we need to write first A is to B, that is argument matrix. So A is where here x, y, z questions, that is 2, 6, no z term 0. Next 6, 20 minus 6, no x term here, so 0, 6 minus 18. Next coefficients, constants, minus 11, minus 3, minus 1. So this is the argument matrix. So we need to do some row operations for getting 0 here and here. So for here to get 0, we need to do the row operation such that this is the R1, first row, second row, third row. So we need to multiply this 2 into 3, then we will get 6, then 6 minus 6 is 0. So R2, this gives rise to R2 minus 3R1, R2 minus 3R1. So that 2, 6, 0 minus 11, there is no change in first one, R1. So R2 is here, first one 6 minus 3 into 2, that is 6 minus 6, 0. So you will get 0. Next 20 minus 3 into 6, 20 minus 3 into 6, 18. 20 minus 18, that is equal to 2. Okay. Next, here we got minus 6 minus 3 into 0, 0 into something 0, so no change, minus 6 only. Next, minus 3 into minus 11, that equal to minus into minus plus, so 33. So here we got 30. Okay, 33 minus 3, that equal to 30. Next, there is no change in this. Okay. Now we got 0 here. Now we need to get 0 here for this operation. Okay. Okay. So next operation is R3 minus same 3R2. 3. Here we got 3 into 2 6, 6 minus 6 0. So that no changes in R1 and R2. So same thing, 0 2 minus 6 30. 0 into something, we'll get zeros only. Next here R3 is here, 6 minus 3 into 2, that is 0. Next third one, third column, number minus 18 minus 3 into minus 6, that equal to minus 18, minus into minus plus 18, 0 only. So here also we got 0. And next minus 1 minus 3 into 30, minus 1 minus 3 into 30, that equal to minus 1 minus 90, that equal to minus 91 we got. So here minus 91. Now rank of A, what? And rank of A argument matrix. Rank of A means this is the A part. So number of non-zero rows. How many number of non-zero rows? Here this is 0 row. I am not considering this. I am considering about A only. Rank of A, for that this is the A part. So in the A part non-zero rows are 2 only. So rank of A is equal to 2. Next, rank of A is to B, that is argument matrix. Now we need to consider whole the matrix. So here this column is now not non-zero, because here we have the number. So that rank of A is to B is 3. So that rank of A is not equal to rank of A is to B. So that therefore what is the nature of solution? Rank of A is not equal to rank of E, no solution. So no solutions, or one more word, inconsistent. Okay, so this is the way we need to do the solution. So I'll give 2 more examples. You people try this. Okay, x plus z equal to 2, x plus y minus z equal to 0. Next one, x minus 4y plus 7z is equal to 14. 3x plus 8y minus 2z is equal to 13. 7x minus 8y plus 26z equal to 5. Okay, these are the 2 examples. You just practice. Next one is eigenvalues. So for finding eigenvalues, eigenvalue equation is A psi is equal to lambda psi. So lambda is here eigenvalue. So A is the matrix. Okay, psi is a function. So where psi is, let psi is equal to xy if A is 2 by 2 and xyz if A is 3 by 3 matrix. So lambda is when stretching or shrinking one, and A psi is equal to lambda psi, and also one more equation. So A minus lambda I is into psi is equal to 0. So if we simplify, we'll get one more equation. So here one some note is there. For A, let lambda 1, lambda 2, lambda 3 are eigenvalues. So for a matrix A, let lambda 1, lambda 2. So how many number of eigenvalues are there means depending on order. If A is 2 by 2 matrix, then the eigenvalues should be 2. If A is 3 by 3 matrix, eigenvalues should be 3, like that. Okay, next, what is trace of the matrix? So trace of the matrix is the sum of eigenvalues. Next, what is det of matrix? So det of matrix is the det of matrix is the product of eigenvalues. Okay, in terms of eigenvalues, trace means lambda 1 plus lambda 2 plus lambda 3, and det means lambda 1 into lambda 2 into lambda 3 into and so on. Okay, so here I am giving 2 examples in 2 by 2 matrix. So let matrix A is 1 0 0 minus 1. Then what are the lambda values? So what is the equation? A psi is equal to lambda psi. Okay, so A means what? So x is, psi is here, x comma y. Okay, so how to find out lambda values? Okay, so for this, A minus lambda I into x lambda I okay into psi is equal to 0. right? So a minus lambda I. So here det of a minus lambda I is equal to what? 1 minute. So a minus lambda I. So here 1 minus lambda 0 0 minus 1 minus lambda is equal to 0. Okay, a minus lambda I. How madam? Why it is not means okay, I'll do. So here a means 1 0 0 minus 1 minus lambda into I is 1 0 0 1. So 1 0 0 minus 1 minus lambda 0 0 lambda. So here only zeros we have, so that we need to do with this elements only. So 0 minus 0 0 only. So 0 minus 1 minus lambda. Okay, like this we got same 1 minus lambda. So det of 1 minus lambda 0 0 minus 1 minus lambda equal to 0. Now AD minus BC 1 minus lambda minus 1 1 minus lambda is equal to 0. So here minus, if we get common, 1 minus lambda 1 plus lambda equal to 0. A minus b into a plus b, 1 square minus lambda square equal to 0. So minus, if we take in this side 0 into something, zeros only. So 1 minus lambda square equal to 0. So lambda square equal to 1, lambda equal to plus or minus 1. So these are the eigenvalues of the matrix 1 0 0 minus 1. And one more, 1 4 2 3. So 1 4 2 3. For this a minus lambda I into psi is equal to 0 means a minus lambda I is equal to 0. So same 1 minus lambda 4 2 3 minus lambda is equal to 0. So AD minus BC 1 minus lambda 3 minus lambda minus 2 4 8 is equal to 0. ABCD det of ABCD equal to AD minus BC. Okay, so simplifying we will get minus 3 lambda plus lambda square minus 8 equal to 0. So lambda square minus 4 lambda minus 5 is equal to 0. Okay, then 2 2s are 4. So when 4 1s are 4 we will get. So lambda square minus 4 lambda minus 5 is equal to 0. One more also there. Ax square plus bx plus c is equal to 0. For this, how to find out roots? X is equal to minus b plus or minus under root of b square minus 4ac by 2a. So this is one more formula. So one more this process. So lambda by common, taking lambda as common, we will get lambda minus 4 minus 1 common here. Okay, we won't get like this. Okay, right, I use this only. So lambda is equal to minus b, that is 4 here. So minus 4 minus plus 4. Okay, plus or minus under root of b is here. Here this is a lambda square plus b lambda plus c is equal to 0. Okay, so b is minus 4, c is minus 5. So 4 square minus 4 into a is 1 into c is minus 5 by 2 into 1. So 4 plus or minus 16 minus into minus plus 20 by 2. So 4 plus or minus under root of 36 by 2. 36 root is 6. So I did some mistake, I think. So 4 plus 6 by 2, 4 minus 6 by 2. 4 plus 6, 10 by 2 minus 2 by 2, that is 5 comma minus 1. Okay, right, here we need to write 5 lambda minus 1. Okay, anyway, lambda values are 5 comma minus 1. So this is the way how to find out eigenvalues for 2 by 2 matrix. And one more characteristics equation we have, so that is lambda square minus trace into lambda plus det is equal to 0. Okay, so if we know lambda values by using this equation also, we can, okay, so for example here 1 2 3 4, so how to find out right, trace. First find out trace value. Trace means here trace is the 1 plus 4, so diagonal elements 1 plus 4 that equal to 5. Next det, we need to find out det. 1 into 4, 4 minus 6, that equal to minus 2. Now the equation is lambda square minus 5 lambda, det is minus 2 equal to 0. Now by using this equation we can find out the lambda values. Okay, this is one more model. Okay, this is the way how to find out eigenvalues. Next, eigenvectors. So how to find out eigenvectors? Okay, so here I am taking one example. So for this we need to find out first lambda values. So I am using this equation lambda square minus trace into lambda plus det is equal to 0. So here trace equal to what is trace? That is the sum of diagonal elements, 0 plus 0 0. And next det equal to how much? 0 minus into minus of minus I into I, AD minus BC, that equal to 0 minus it minus plus I square, that equal to I square is minus 1. So trace is 0, det is minus 1, so that lambda square minus 0 minus 1 equal to 0, that is lambda square minus 1 equal to 0. So lambda square equal to 1, so lambda equal to plus or minus 1, sorry, root 1. For root 1, yeah, plus or minus. Now how to find out eigenvectors? So for that first I am taking lambda is equal to plus 1. Now I am using a psi is equal to lambda psi. A is 0 minus I 0, psi is x comma y, lambda is equal to 1 x comma y. Now we know matrix multiplication and we need to equate here. First one is 0 into x plus 0 into x plus this one minus I into y is equal to 1 into x, first one. So 0 into something 0 plus minus iy is equal to x. So y is equal to x by minus I. Okay, or here minus here also we can write, so ix, that is I minus 1 means what? I square. So I square, I'll write here minus 1 means I square into x by I cancel, so ix. So y is equal to ix. Next equation is this one, I into x plus 0 into y is equal to 1 into y. So same, ix is equal to y, that is y is equal to ix. Now psi is equal to what? X comma y. Now in the place of y I'll write x comma ix. So if you remove x, in the place of x I am writing 1, so 1 comma I. This is one eigenvector. Okay, so here how to find out eigenvector? A psi is equal to lambda psi. First we need to find out lambda values, that is eigenvectors, eigenvalues. So in that we got two eigenvalues, plus 1 minus 1. Now I am taking one eigenvalue, that is 1. So using a psi is equal to lambda psi, substituting and using matrix multiplication, first matrix multiplication, second matrix multiplication, 0 into this one, 0 into this. So we need to equate this one, and next this element, next second one, I into this one, 0 into this one equal to 1 into y. So by simplifying this and substituting y value in the x comma y, so we got one vector. And second one using lambda is equal to -1. Same a psi is equal to lambda psi. A is what? 0 minus I 0, I 0 into psi is x comma y minus 1 into x comma y. Same thing, 0 into x 0 minus I into y minus I into y minus iy is equal to minus x, so that x is equal to iy. Okay, so no need to do second one, directly I am substituting in the x psi is equal to x comma y. In the place of x I am substituting y, iy comma y, so that we got it here I comma 1. This also, but in the option this one is, we won't get, one more will do. So ix is equal to minus y, or y is equal to minus ix. Okay, so in the place of y I will substitute this, so x comma minus ix, so that answer is 1 comma minus I. Okay, 1 comma minus I. So this is the answer. So eigenvalues are, first one is 1 comma I, second one is 1 comma minus I. So these are the eigen vectors of this one, 0 minus I 0. Okay, so this is the process how to find out eigenvectors. In the last topic in the matrices, that is Cayley-Hamilton principle, theorem. So what is Cayley-Hamilton theorem? Every matrix satisfies its own characteristics equation. Every matrix satisfies its own characteristics equation. What is characteristic equation? So let the characteristic equation is lambda square minus 3 lambda plus 2. We got in our while finding lambda values, we got one equation, that is a characteristic equation. So now according to Cayley-Hamilton theorem, every matrix satisfies its own character, means in the place of lambda we need to substitute a matrix A, so that a square minus 3a plus 2 nothing is there, means I in the matrices form I, that is 2 into 1 means here I, so 2i is equal to 0. So this is the characteristics equation, and this is the Cayley-Hamilton theorem. So what is the application of Cayley-Hamilton theorem is finding of inverse. Okay, so for example I am taking one example. If lambda cube plus 2 lambda square minus 3 lambda plus 4 equal to 0. So before going to this so here some notes in eigenvalues. So for triangular or diagonal matrix, eigenvalues are diagonal elements. Okay, for triangle matrix or diagonal matrix, so this is the diagonal matrix. So what are the eigenvalues of these diagonal matrices? Lambdas are a, b, c, directly diagonal elements. And also for example a, b, c, 0, d, e, 0, 0, f something is there. So this is the upper triangle matrix, either upper triangle matrix or for lower triangular matrix. So these diagonal elements only lambdas. Okay, that is eigenvalues. Next, for a matrix whose rows or columns are identical, if two rows are equal, not all the three, if only two rows or two columns are equal or all the columns are equal, then what are the eigenvalues are? Simply lambdas are trace comma 0 0. How many zeros means it is up to n minus. So for example this is a 3 by 3 matrix. So first lambda is what? Trace is what? A plus a plus a, that is the sum of diagonal element, that is 3a comma, how many zeros we need to write means, so totally 3 by 3 for 3 by 3 matrix, 3 lambda values we need to know, we need to write. So here 2 zeros will get, that is 3 minus 1 2. So 3a comma 0 comma 0. For example here one more example, 1 2 3 2 4 6 3 6 9. If we observe, this is not same, but these are identical. How means here 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is 6, into 2 into 2 into 2 if we do this one, and into 3 into 3 into 3 we will get this one, 1 into 3, 2 into 3 6, 3 into 3 9. So these are identical rows and columns, so that, and here this same we will get same thing. So for this also this trick is applicable, that is trace comma zeros. So 1 plus 9 is 10 plus 1 plus 4 is 14, so that 14 comma 0 are lambda values. Okay, and we have some notes here. If lambda 1 lambda 2 are the eigenvalues of A, then A power m eigenvalues are same powers, lambda 1 power m, lambda 2 power m, like that. If then what are the eigenvalues of K are same, K lambda 1, K lambda 2, A transpose are same. For A transpose the eigenvalues are same. For A inverse 1 by lambda 1, 1 by lambda 2, 1 by lambda 3. For adjacent A, adjoint A, det A by lambda 1, det A by lambda 2, and so on. For orthogonality, A transpose equal to A inverse. For unitary, A dagger is equal to, this is the dagger not transpose, is equal to A inverse. Okay. So what is dagger? All the things I explained in previous theory. Now we'll see one example in Cayley-Hamilton theorem application. That is, if this is the characteristic equation of A, then what is the characteristic equation of A inverse? So how to find out this means? Now here for A, if lambda 1, lambda 2 are the eigenvalues, then A inverse eigenvalues are 1 by lambda 1, 1 by lambda 2, like that. So directly in the characteristic equation, for finding characteristic equation of A inverse, we need to directly substitute in the place of lambda 1 by lambda. So here lambda cube plus 2 lambda square minus 3 lambda plus 4 equal to 0. So that for A inverse characteristic equation is 1 by lambda cube minus 3 into 1 by lambda plus 4 equal to 0. Now we need to simplify this. So 1 by lambda cube plus 2 by lambda square minus 3 by lambda plus 4 equal to 0. Now LCM, we get lambda cube. So 1 plus 2 lambda minus 3 lambda square plus 4 lambda cube equal to 0. 0 into something 0. So that first write 4 lambda cube minus 3 lambda square plus 2 lambda plus 1 equal to 0. This is the characteristic equation of A inverse. Okay.